Let's take a look at some of the word problems on section 5.4. And for many of these problems, especially at the beginning, you can solve these problems by setting up a table of values and finding your slope. Okay, so for question number 1, we're dealing with an insurance company that's buying computers, and the value of computers after 2 years is now worth $80,000, and after 4 years, the computers are worth $56,000. And the question's asking, determine the purchase price of the computers. All right, as mentioned, you can start off a lot of these problems by creating a table of values. So my table of values is kind of set up here already. Let's label the x-axis as time, so maybe time in years, and we'll label the y-axis as value, so maybe a dollar value of what the computers are worth. Okay, so after 2 years, the computers were worth $80,000, right? So after 2 years, the computers are worth $80,000. Let's input those numbers into the table of values. And then after 4 years, the computers were worth $56,000. And if I want to find the purchase price of the computers, I'm pretty much asking, when time is 0, what is the dollar value of those computers, right? So that's the purchase price of the computers. All right, so over here on the right-hand side, I do have my slope formula set up, and let's go ahead and find the slope here. I will go ahead and label this as y2, this will be y1. So if I go ahead and use my slope formula here, that'll be 56,000 minus 80,000 all over the difference in x values, and my x values are over here, so this is going to be x2 and x1. So 4 minus 2 on the denominator. Okay, and if you go ahead and just calculate this, you get negative 12,000 on the numerator, and on the denominator, I'll have just a 1 there, right? So go ahead and put that into your computer, and you will get negative 12,000 over 1. And what that means is every year the computers lose $12,000 in value. Okay, so knowing that, if I just kind of box this for now, this means every year the computers are losing $12,000 in value. If I take a look at year number 1, we're just going to subtract $12,000. So we're going to add $12,000 to the price because we're going backwards, right? So if I do that, we get $92,000, and for the beginning, we would now add another $12,000 to the price from year 1, and that would mean the computers are worth $104,000 when you initially buy them, right? And if you want to find like the third year here, this is the case where you would subtract $12,000, right? So if you're going down in years, you would subtract $12,000. If you want to go backwards to the beginning of time or the beginning of the problem, then you would add $12,000 to the purchase price. Okay, let's move on to question number 2 now. For question number 2, the storyline is, in her first year of practice, a psychologist has 160 patients, and by her third year, the number of patients has grown to 246. If this trend continues, how many patients would she have in her 4th year? Okay, so let's label the x-axis as the year. Usually time is going to be on your x-axis, and then on the y-axis we'll have the number of patients. Okay, all right, so let's go ahead and reread the problem here. So basically, in her first year, so in year number 1, there are 160 patients, so 160 patients in year 1. And by the third year, the number of patients have increased to 246 patients. And now the question is, how many patients are there in the 4th year, right? Okay, so once again, let's go ahead and create a table of values here. So we'll label this as y2, and this will be y1. This will be x1, and sorry, not x1. This will be x2 and x1. So once we label those points there, let's go ahead and insert those numbers into the slope formula here. So this will be 246 minus 160 all over 3 minus 1. Okay, and if we put that into the calculator, we get 43. And this is really the same thing as 43 over 1. So every year, the number of patients is going up by 43. Okay, so if I just erase all this, okay, so if I go from year 3 to year 4, I just add another 43 patients. All right, so once again, how do you read the slope here? When when you put all of this into the calculator, you get 43, and what that really means is every year the number of patients will go up by 43. So if I add 43 to 246, I get 289. Okay, let's move on to question number 3 now. Let's move on to question number 3. And for question number 3, the percent of 18 to 25-year-olds who smoke worldwide has changed from 46.8% in 1987 to 37.2% in 2000. And we want to predict the percentage of 18 to 25-year-olds that will smoke in 2012. All right, so here's my table of values here. And on the x-axis, I'll label this as year. And on the y-axis, we'll label this as the percentage of smokers. And let's go ahead and just input the data into the table of values here. So in 1987, the percentage of smokers was 46.8%. And in the year 2000, the percentage of smokers was 37.2%. And the question is, we want to predict the percentage in 2012. Okay, so just like the previous questions, we definitely want to find the slope here, and that will kind of tell us what's happening every year. So let's label this as y2, let's label this as y1, this will be x2, and this will be x1. And if I use my slope formula here, this will be a 37.2 minus 46.8, all divided by the year 2000 minus 1987. Okay, and if I input that into the calculator there, you would get negative 0.73846. Okay, so we get a weird number there, and what that really means is that every year, if I put this over 1, every year the percentage of smokers is decreasing by 0.73846 percentage points. Okay. So knowing that fact, let's go ahead and just erase some of this. Let me also erase this. All right, so our goal is we want to go from 2000 to 2012, right? So right now in 2000 is 37.2. But based on this fact right here, every year we're going down by 0.73846 percentage points, right? So going from 2000 to 2012, there's a 12-year difference, right? There's a 12-year difference here, right? So we can take our 37.2 percentage points in the year 2000 minus, well, there's a 12-year difference between 2000 and 2012, and we're going down by 0.73846 percentage points. And if you actually calculate this and put that into your calculator, you should get 28.33. Okay, so 12 years later from the year 2000, the percentage of smokers worldwide is now 28.33 percentage points. And that's because every year we go down by 0.73846 percentage points. Okay, so that's it for question number 3. Let's move on to question number 4 now. For question number 4, a taxi cab is purchased for $36,000, and at the end of 10 years, it's sold for scrap for $1,800. Find the depreciation equation. Okay, so anytime you're asked to find an equation in Chapter 5, you can always start off by writing y equals to mx plus b, right? And we know that this is your slope, and we know this is your y-intercept. Okay. Let's go ahead and set up a table of values here. So we're dealing with money and time, so I'll put time over here, and I'll put money over here on the y-axis there. Okay, so the taxi cab is purchased for $36,000. So at the very beginning, it is purchased for $36,000, and then 10 years later, the car is basically worth just $1,800. Okay, so let's go ahead and figure out the slope, because slope is this m value here. So we'll label this as y2, y1, x2, and x1. And if I go ahead and find the slope, it's really the y2 value. So the y2 is 1,800 minus the y1 value, which is 36,000, all divided by x2, which is 10, minus x1, which is 0. So my slope, if I put that all into the calculator there, I get negative 3,420. So what that really means is what I normally do is I always put this over 1 because it's a little bit easier to explain the slope if it's over 1. So every year the value of the car is losing value by $3,420. That's what that slope means. Okay, so let's go ahead and just go back to our equation here. So that means I have y equals to negative 3,420x plus. Now, what is the y-intercept? Well, the y-intercept happens whenever the x value is 0. So here's your y-intercept right here. It's actually going to be $36,000. Okay, and although this is pretty good here, I believe the back of the book kind of has different variables instead of y and x. So maybe for time we can use the letter n, and maybe for the dollar sign or value we can use the letter v. All right, so if I change this using the right variables, y would be v, so negative 3,420, and x would now be the number of years, which will be n, and then we can add the $3,600, or the $36,000. Okay, so that's it for part 1. We'll do part 2 a little bit later on.